Hello everyone, today I'm presenting a paper understanding execution environment of file manipulation scripts by extracting preconditions. So file manipulating scripts are widely used in nowadays software production process. For example, like shell scripts, like Dockerfile, they are widely used as like standalone software or in the build process. So most of these file manipulating scripts, they make assumptions on directory structures. Also, they may have some different execution paths with different inputs and configurations. So using pure dynamic analysis may not exercise all the paths. So in this work, we propose a static analysis to find out the precondition of running file manipulating scripts successfully. The key idea of our work is that a directory structure or a file system state can be viewed as a set of path strings, and thus it can always be presented as an automaton. So for example, in the following sample code, we will make a temp directory, and then we are, in some cases we touch ABC inside it, in other cases we touch DEF outside it. And we can see on the right hand side we show the file system state automaton at the end of the above program. So we show the state, abstract state of the file system at the end of running the script. So based on this abstraction domain, we are able to define the transfer functions for preconditions. In particular, we consider four basic operations: touch, make directory, copy, and remove. Other commands can be translated to these four. So we have two domains. The one is the existence precondition domain, which means that the path needs to exist. And the N means the negative precondition domain, which means that the path must not exist. So we can see, for example, in the touch one, N is equal, after the analysis goes through this, like touch X operation, we know that this path X must not existing, and the path parent directory of X must exist, because you have to have the parent directory existing to touch like a file. So similarly, we have other things for the make directory, for the copy, for the remove. For example, in the copy XY, we need the Y folder plus the base name of X may not exist, but the X itself must exist in the path. So to present the operations on automatons, such as the parent directory and base name, we're using finite state transducer. For example, this finite state transducer simulates a base name operation. So given any path, this finite state transducer is creating the base name for that path. If the given input is automaton, then it will get the automaton for the base name part of the path, of all the paths in the automaton. So our initial results on 60 Docker files from Awesome Docker shows that our analysis is are able to create precondition with a size from 2 to 88 with a median of 26 nodes. At the same time, the execution time is within 1 second. So thanks. Any questions?
Hello everyone. I'm Iftikhar Ahmed. Due to some technical difficulties, the author is not present right now. So please leave your questions in the paid chat, and then the author can answer them later on. Thank you.